Alright guys, in this video I will be working through, or I'm doing two problems like numbers 1 and 2, and then I'm working out 3 through 6 completely and showing you how to type your answers in, and then you will be able to do 7 through 12 independently, okay? So make sure you are adding this to your notes. If you would like, go ahead and pause the video and copy to here. That way I can explain this stuff to you, and then you'll be able to go to problems 1 and 2 and work them out, okay? And they're not necessarily in the same order, but they're the same types of problems, okay? So this, again, is based on your product and sum rules that you just took notes on. And the first thing I would recommend that you do is, in your notebook, when you write down these problems, like for number 1, when you get to number 1, write down if they're rational or irrational. And then you can refer back to your notes page. So 0.25 is a terminating decimal, which is rational. 0 times pi is just equal to 0, and 0 is rational. So this is rational times irrational. So what do we know about irrational times irrational? If you look back at your notes, irrational times irrational is always rational. So in Deltamath, you would just type in an R. So in the instructions I tell you, just type in R or type in I. If we take a look at B, and like I said, they're not necessarily in the same exact orders of the problems, but A through D on Deltamath is contained within A through D here for number 1. So I said it's like number 1. So if you take a look at B, this first number here, it's a what? It's repeating decimal, but it's not, I'm sorry, it's non-terminating, but it's not repeating. So it does not terminate, it does not repeat. So this 0.674 with this ellipses is irrational. And 2.5 is a rational number because it's a terminating decimal. So what's going to be true? I plus R is I unless what? And I plus R, actually, no, I think I plus R, we went over, was always rational, or irrational. So an I plus R is always going to be irrational. And then for C, the square root of 5, is the square root of 5 a perfect square? No. So this is an irrational number. Is the square root of 20 a perfect square? No. So this is an irrational times an irrational, which there's an exception to the rule. So that means we need to multiply this out. So if I take the square root of 5 and multiply it by the square root of 20, then that means I multiply the 5 with the 20. And what's 5 times 20? 100. Oh, and what's the square root of 100? It is 10. Therefore, it is going to be rational. And then D, this is a ratio of two integers, so it is rational. And this is a terminating decimal, which is rational. And we know that a rational plus a rational is always rational. Can we type this in our calculator? Yes. In fact, you could type in A. B you wouldn't be able to type in because of the ... But C you could type in your calculator. D you could type in your calculator also, and see if you can convert them to a fraction. If you can convert it to a fraction, that's a ratio, therefore the answer would be rational. So again, assuming that you paused the video and already copied these down. The square root of 9, we can actually simplify this, and that's equal to 3. So this is a rational number times the square root of 2, which is irrational. And remember, unless our rational number is 0, a rational times an irrational is always what? We should be looking back at our notes. A rational times an irrational is always irrational unless the rational number is 0. And it's not 0, it's 3. Because it's the square root of 9, which simplifies to 3. But of course, like I said, you can convert this, you can type it in your calculator. You could also think of this as multiplied together being the square root of 18, and the square root of 18 is a non-perfect square, so it's another way to think about it. If we take a look at B, this time we have two irrational numbers, but what do you notice about these? If you look back at your notes, on the front part of the page, you should see that these are opposites, right? And since they're opposites, it's going to equal 0, and therefore we're going to get a rational number for this type of example. Now for C, the square root of 7 plus the square root of 5. Let's see let me tell you something that students like to do, but it's not correct. So some students will go, oh, well, if I can multiply the square root of 9 times the square root of 2 and get the square root of 18, then does adding mean I add 7 and 5? Well, let's see. If I type in the square root of 7, try to make sure you can see it. If I try to type in, I'm going to focus it. The square root of 7 and plus add to it the square root of 5, I get this decimal number. Is that the same thing as the square root of 12? No. So I can't add 7 plus 5 and get 12 together. In fact, this is wrong altogether. However, what do you notice about this? You get an irrational value when you add this. So this is going to be irrational, and it's because you're adding two irrational numbers, and you get an irrational unless they're opposites. And then back to multiplication this time. I have an irrational times an irrational. So remember, it's always irrational unless the product gives us what? So keep in mind, this is the square root of a non-perfect square times the square root of a non-perfect square. So are we getting a perfect square or a non-perfect square when we multiply 3 times 7? We get 21. So that's a non-perfect square, therefore it's irrational. So if you want, after adding these, you can pause the video and then go try numbers 1 and 2, because this is not exactly like 1 and 2 on Deltamath. It's like 1 and 2. I am going to continue the video and do 3, 4, 5, and 6 to teach you how to multiply these radicals together, okay? So I am going to refer back to the Deltamath assignment and look at number 3. So again, if you look at number 1, by the way, it looks very similar, okay? So it says determine if the following sums or products are rational or irrational and type R or I as your response. So be sure to look back at the examples we just went over for 1 and 2 to help you with these, remembering that you can type them in your calculator as well. For number 3, if we take a look at this problem, and I'm in teacher view, so it looks different from yours, but here's your problem for 3. It says find the sum of the square root of 9 and 5 square roots of 4 in simplest form. Also, determine whether the result is rational or irrational and explain your answer. So you're actually going to have to type in the answer, and then you would press that. That's a button you can press if it's a square root. I just hit delete, so it went away. And then you have these drop downs, okay? So you have to decide, is my result, so is this number here, irrational or rational, because it can or cannot be written as the ratio of two integers, and its decimal expansion does or does not terminate or repeat. So I'll give you a little more detail after I talk about how to answer this. So if you take a look at number 3, you can type this in your calculator to see if you get rational or irrational, but if it's an irrational answer, you're going to get a long decimal, and you cannot type that in Deltamath. So I'm going to show you how to do these. The first thing I want you to recognize is that we should be pretty familiar with the square root of 9. This happens to be the square root of a perfect square, and this square root of 4 is also a perfect square. So if I simplify these, the square root of 9 is what? It's 3. And then I'm adding to it 5 times whatever the square root of 4 is, and the square root of 4 is what? 2. Now, of course, our order of operations says we multiply first, so that's 10. So really the value of this number is 10, and the value of this number is 3. When I add those together, I get 13. And 13 is a rational number. So make sure you're adding this in your notebook, because like I said, when you take your quiz tomorrow, you will be able to pull out your notes and have these nice examples to look at, because your quiz will look like your Deltamath practice problems that you've already done. So I'm going to go in here and type in that our result is 13, which we know to be a rational number. And remember, rational numbers can be written as the ratio of two integers, and it does repeat or terminate. So if you look at a whole number and say, what do you mean it repeats or terminates? No, it doesn't repeat, but I can write it as a terminating decimal as in 13.0, which terminates. But clearly there's nothing that keeps going if you have, but in terms of a decimal form, it's 13.0. So things to keep in mind: can and does go together, and cannot and does not go together. So keep those in mind too. So I'm going to hit submit, and there again, it explains everything just like I said. 13 can be written as 13 over 1, and it terminates, okay? All right, and then next I'm going to show you how to do number 4, because it's definitely different. So if we look at 4, I see 5 square roots of 2, which really is the same thing as just saying 5 times the square root of 2, and here we're multiplying that by 5 times the square root of 23. So things to keep in mind: this is an irrational number. The whole number, this whole thing together is irrational. So because we can't take the square root of 2 and we can't take the square root of 23. But what we do, if we look back at our notes, we would go, oh, well, I'm supposed to know. Well, let's look at my rule. What's true about an I times an I? So an I times an I, I'm trying to find my notes. It's in my notebook. Right, nope. Right here. An I times an I is I, except when we get the square root of a perfect square. An I times an I is I, except when we get the square root of a perfect square when we multiply. So let's see what happens when we multiply. So what's new is learning how the heck do I even multiply these things. So when you multiply them together, notice that you have a rational number on the outside. You're going to multiply these together. So any numbers on the outside. So 5 times 5 is 25. Then I'm going to multiply these numbers together and put them under here. And what is 2 times 23? It's 46. Okay? Now, I can't take the square root of that because it's not a perfect square. You are going to learn how to simplify square roots later, but that's all you're going to need to do. Multiply the numbers on the outside, multiply the numbers on the inside, and keep them there. And because I do not get, the product here is not a perfect square, I'm just going to end up with an irrational value. And I can verify that, of course, in my calculator. Could I type all of it in my calculator? Sure. I could do 5 square root 2, hit the right, sorry, you can't even see that. I'm just typing in what I got here. I'm going to start over. So when I type in 5 square root 2, notice that my red bar is still under the radical. I need to hit the arrow on the right here to get out of the radical. Then I'm going to type in 5 square root, oops, I should have hit times 5 square root 23. Now I'm going to get this irrational decimal. So that's not going to help me except to tell me it's irrational. I'm not going to be able to type in the result by doing this. So I do have to know how to do this on paper, okay? Now, can I verify that 25 square root 46 makes sense? If that's what I get when I multiply it on paper and I press enter, my decimal value should match. That tells me that this expression that I got when I multiplied is equivalent to my original problem. Still get an irrational value, but it's not going to spit out 25 square root 46 for you. So I'm going to put irrational, but in here, when I go to type in my answer for 4, notice it says in simplest form. So I have to type in 25, then come over here. So let me come over here. I'm typing this answer here into my result box. So 25 square root 46. And don't make it hard, guys. We're just multiplying the numbers on the outside together and the numbers on the inside together. And then it's irrational because it's the square root of a non-perfect square, right? And that means it cannot be written as the ratio of 2 integers, which means it does not terminate or repeat. In fact, remember the decimal, it does not terminate and does not repeat. If we got that many decimals, it's going to go on and on forever with no repeating pattern. So I'm going to hit submit. And it's correct. Notice they're doing the same thing. They're telling you to multiply the 5 and 5 together and then multiply the 2 and the 23 together. And it cannot be further simplified. So we are left with an irrational number. All right, I'm going to move on and try 5 and 6. If you feel like you got this, just work them out and then listen to my video. Hit the pause and see if you get them right. For number 5, if you notice, it's pretty much the same thing except we've got the square root times itself. So let's do what I taught you up here. We're going to multiply the numbers together out on the outside. So 4 times 5 is 20. And then the numbers together on the inside. So I'm just going to pick up my calculator and type in 27 times 27. And that gives me 729. Well, is that a perfect square? Well, what is the square root of 729? Oh, weird. We just got 27. So we bring this down, and this is 20 times 27. And 20 times 27 is 540. So we get an integer, or a whole number, or a counting number. So that's rational, okay? So generally, really what's going on is when you multiply a radical times itself, it drops the radical. So that's the key. If your numbers under the radical are the same, you're just going to end up dropping that radical. If you think about the square root of 3 times the square root of 3, guess what we're going to get? The square root of 9, which equals 3. Does that make sense? The square root of 5 times the square root of 5 gives us the square root of 25, which is just 5. So anytime we multiply a square root times itself, it just ends up dropping the radical and leaving the number underneath. Okay? So that's rational. So I'm going to go over here to 3 on Deltamath. And I'm going to type in 540 because that's the simplest value we got. And of course, these always go together. If it's rational, it can be written as the ratio of two integers, and it does terminate or repeat. All right. And then you've got your explanation. If at any point you're feeling a little stuck on these guys, just want to remind you that you can hit watch help video. You can, you'll have show examples up here when you're in your student view. And you can click on show examples to have it work out some stuff for you. Or you can look at how some of them are worked out to help you as well. And almost done. Last one. I'm going to be done with this video. 4 square roots of 2 is how you would say that. 4 square roots of 2, or 4 root 2, plus root 5. Well, can we take the square root of these? No. So this is an irrational plus an irrational, which is irrational unless they're opposites, right? So we can probably go ahead and go, oh, they're definitely irrational. And in fact, can I even add these two numbers together? Remember I just showed you how you cannot add the square root of 2 and the square root of 5 like you can multiply, okay? So don't make that mistake. And in fact, you cannot do anything to simplify. This is the answer. In fact, the only other way to rewrite this is if you were to use your property that says you can switch it around. Does anybody remember what that property is called? It's called the commutative property, right? Same as 5 plus 2 is 7. That's the same thing as 2 plus 5 is 7. So we can switch these around, but that's it. These are the only two appropriate ways to write our answer when it's addition of two irrational numbers. So remember, an irrational plus an irrational is irrational unless they're opposites. So I'm going to go over here. Let me slide this so you can see. And I'm just going to type it in exactly how I see it. 4 root 2, and then I'm going to hit the right arrow to get out of my radical, plus, so I'm going to hit shift plus, and then root 5, square root 5. And it is irrational. Remember, irrationals cannot be written as a ratio of two integers because they do not terminate or repeat. If I were to put this in my calculator, I get a long, crazy decimal. So I'm going to hit submit. And that concludes half the assignment. So I've now basically walked through 1 through 6 with you, and your job is to do 6 independently. So go ahead and finish 7 through 12, and let us know if you have any questions. Good luck.